So why is a synthesis reaction called a dehydration reaction? Well, when we look at what we've got here, we've got our reactant A and our reactant B. And right now, they're very stable molecules just by themselves. And they don't really have any place where they can create a new union. So as these two reactants exist, there's no way for them to come together. So we have to break a bond on each one of these two reactants. We have to break a bond on A and break a bond on B in order for us to create a spot where the two can come together. Now, Mother Nature looks around, and she typically likes to look for a hydrogen somewhere and a hydroxide somewhere, because those are going to be like perfect things for her to just snap off. Not literally, but hopefully you get the idea. So if we break the bond of the hydroxide with our reactant A, and we break the bond with the hydrogen off of our reactant B, then essentially what we've done is we have liberated two hydrogens and an oxygen between these two reactants. And if we give those atoms an opportunity to come together, we create a molecule that has two hydrogens and an oxygen, and we call this water. So by bringing our two reactants together, we basically remove a water molecule. Now, it didn't exist as a water molecule because all the atoms were spread out between the two reactants. But once we remove the right atoms, that hydrogen and that hydroxide, we remove those. Now we're creating a water molecule in the process. But at the same time, we're also creating a spot where A can join to B and B can join to A. And when we do, we create a larger substance known as AB, and we leave behind a water molecule. So that's why it's called a dehydration reaction.